National Electrical Code Section 680.42, paragraph C, addresses the requirements for equipment grounding conductors, often abbreviated as EGC, used in the supply circuits for spas and hot tubs that are installed outdoors. This section explicitly states that the equipment grounding conductor must be insulated or covered. This requirement exists to provide an additional layer of safety in potentially wet or damp outdoor environments. The inspector's requirement that equipment grounding conductor, often abbreviated as EGC, be insulated is likely correct because typical Romex cable used inside the house usually has a bare and insulated equipment grounding conductor. The specific language of the code requires this insulation or covering when a hot tub or spa is installed outdoors. In addition to insulation requirements, the National Electrical Code, often abbreviated as NEC, mandates that the equipment grounding conductor, often abbreviated as EGC, for a spa or hot tub be properly sized. This sizing is determined by referring to Table 250.122 in the National Electrical Code. This table provides guidance on the minimum size of the equipment grounding conductor based on the overcurrent protective device, such as a circuit breaker or fuse protecting the circuit. For a one-family dwelling, the equipment grounding conductor, often abbreviated as EGC, must be sized at least as large as the ungrounded conductors of the circuit. This means that if the circuit conductors are 6 American wire gauge copper, the equipment grounding conductor, often abbreviated as EGC, must also be at least 6 American wire gauge copper. The information provided does not explicitly state whether the equipment grounding conductor, often abbreviated as EGC, in the polyvinyl chloride conduit is appropriately sized. The inspector would likely require verification that the equipment grounding conductor, often abbreviated as EGC, is both insulated and sized correctly to approve the installation. It's important to emphasize that electrical codes can vary from one jurisdiction to another. These variations can be due to local amendments or interpretations of the National Electrical Code, often abbreviated as NEC, or other regional or municipal regulations. To ensure compliance and safety, it is always best practice to consult with the local electrical inspector before commencing any electrical work. Consulting with the inspector can help clarify any specific requirements or interpretations that apply in the area. When installing a hot tub or spa, several key electrical components and considerations must be addressed to ensure safety and compliance with electrical codes. Firstly, a disconnecting means is essential. This allows for the complete disconnection of power to the hot tub or spa for maintenance or emergency purposes. The disconnecting means must be readily accessible and located within sight of the hot tub or spa, typically no more than 50 feet away. Secondly, ground fault circuit interrupter, often abbreviated as GFCI, protection is mandatory. Ground fault circuit interrupters, often abbreviated as GFCIs, are designed to detect small current leaks to ground and quickly disconnect power, preventing electrical shock. The hot tub or spa circuit must be protected by a ground fault circuit interrupter, often abbreviated as GFCI, and the ground fault circuit interrupter, often abbreviated as GFCI, should be tested regularly to ensure proper function. Thirdly, bonding is a critical safety measure. Bonding involves connecting all metallic parts of the hot tub or spa and any nearby metallic structures such as fences or handrails to create an equipotential plane. This helps to minimize the risk of electrical shock by ensuring that all metallic parts are at the same electrical potential. Fourthly, wiring methods must comply with the National Electrical Code, often abbreviated as NEC. This includes using appropriate types of cables or conductors, proper conduit installation, and correct wiring connections. The wiring must be protected from physical damage and installed in accordance with all applicable codes and standards. Fifthly, overcurrent protection is necessary to protect the circuit from overload or short circuit conditions. This is typically provided by a circuit breaker or fuse sized appropriately for the circuit. The overcurrent protection device must be readily accessible and properly rated for the application. Sixthly, the equipment grounding conductor, often abbreviated as EGC, plays a vital role in safety. As previously mentioned, the equipment grounding conductor, often abbreviated as EGC, must be properly sized and insulated, and it must be connected to the grounding system of the electrical panel. This provides a path for fault current to flow back to the source, tripping the circuit breaker or fuse and preventing electrical shock. Seventhly, underwater lighting must be installed safely. Underwater lights must be specifically designed for use in wet locations and must be installed in accordance with the manufacturer's instructions and electrical codes. They should be ground fault circuit interrupter, often abbreviated as GFCI, protected and properly bonded. Eighthly, clearance from overhead power lines is essential. Hot tubs or spas must be located away from overhead power lines to prevent the risk of electrical shock. The National Electrical Code, often abbreviated as NEC, specifies minimum clearance distances from power lines, which must be strictly adhered to. Ninthly, signage is important. Install appropriate warning signs near the hot tub or spa to remind users of safety precautions, such as not using electrical devices near the water and avoiding use during thunderstorms. Tenthly, regular maintenance is crucial. Regularly inspect the hot tub or spa and its electrical components for any signs of damage or wear. Any necessary repairs or replacement should be performed by a qualified electrician. The National Electrical Code, often abbreviated as NEC, is a comprehensive set of standards and guidelines for electrical installations. It is updated regularly to reflect new technologies, safety practices, and industry best practices. Compliance with the National Electrical Code, often abbreviated as NEC, is essential to ensure the safety of people and property. The National Electrical Code, often abbreviated as NEC, Article 680 covers the requirements for swimming pools, fountains, and similar installations, including hot tubs and spas. This article provides detailed guidance on all aspects of electrical installations related to these types of equipment, including wiring methods, grounding, bonding, ground fault circuit interrupter, often abbreviated as GFCI, protection, and more. Key sections of Article 680 include Section 680.21, which covers the wiring methods permitted for use in and around pools and spas. It specifies the types of cables and conductors that are allowed, as well as the requirements for conduit installation and protection from physical damage. Section 680.22 addresses the requirements for equipment grounding and bonding. It specifies the types of equipment that must be bonded, the methods for bonding, and the size of the bonding conductors. Section 680.23 covers the requirements for ground fault circuit interrupter, often abbreviated as GFCI, protection. It specifies the locations where ground fault circuit interrupters, often abbreviated as GFCIs, are required, as well as the performance requirements for ground fault circuit interrupters, often abbreviated as GFCIs. Section 680.26 provides guidance on the requirements for equipotential bonding. It specifies the metallic parts that must be bonded together to create an equipotential plane around a pool or spa. Section 680.42 specifically addresses the requirements for spas and hot tubs. It covers topics such as the location of the disconnecting means, the wiring methods permitted, and the requirements for equipment grounding. The equipment grounding conductor, often abbreviated as EGC, is a critical component of the electrical system. It provides a low impedance path for fault current to flow back to the source, allowing the overcurrent protection device, such as a circuit breaker or fuse, to trip and energize the circuit. The equipment grounding conductor, often abbreviated as EGC, must be properly sized, installed, and connected to ensure its effectiveness. The size of the equipment grounding conductor, often abbreviated as the GC, is determined by Table 250.122 in the National Electrical Code, often abbreviated as NEC. This table provides guidance on the minimum size of the equipment grounding conductor, often abbreviated as EGC, based on the rating of the overcurrent protection device. For example, if the circuit is protected by a 20 amp circuit breaker, the minimum size of the equipment grounding conductor, often abbreviated as EGC, is 12 American wire gauge copper. The equipment grounding conductor, often abbreviated as EGC, must be installed in accordance with the National Electrical Code, often abbreviated as NEC. It must be protected from physical damage and installed in a raceway or cable assembly. The equipment grounding conductor, often abbreviated as EGC, must be connected to the grounding system of the electrical panel. This provides a direct path for fault current to flow back to the source. Ground fault circuit interrupters, often abbreviated as GFCIs, are life-saving devices that protect against electrical shock. They work by monitoring the current flowing in the circuit and detecting any imbalances between the hot and neutral conductors. If a ground fault is detected, the ground fault circuit interrupter, often abbreviated as GFCI, will quickly trip and energize the circuit, preventing electrical shock. Ground fault circuit interrupters, often abbreviated as GFCIs, are required in many locations, including bathrooms, kitchens, and outdoor areas. They are also required for all receptacles serving hot tubs and spas. Ground fault circuit interrupters, often abbreviated as GFCIs, should be tested regularly to ensure they are working properly. The test button on the ground fault circuit interrupter, often abbreviated as GFCI, should be pressed monthly to verify that it trips and de-energizes the circuit. If the ground fault circuit interrupter, often abbreviated as GFCI, does not trip, it should be replaced immediately. Bonding is the process of connecting all metallic parts of an electrical system together to create an equipotential plane. This helps to minimize the risk of electrical shock by ensuring that all metallic parts are at the same electrical potential. Bonding is required for all metallic parts of a hot tub or spa, including the metal shell, the metal frame, and any metal piping. The bonding conductors must be sized in accordance with the National Electrical Code, often abbreviated as NEC, and they must be connected to the grounding system of the electrical panel. Proper wiring methods are essential for the safe and reliable operation of a hot tub or spa. The wiring must be protected from physical damage and installed in accordance with the National Electrical Code, often abbreviated as NEC. The types of cables and conductors permitted for use in and around hot tubs and spas are specified in the National Electrical Code, often abbreviated as NEC. These include types UF, THHN, and XHHW. Conduit is often used to protect wiring from physical damage, especially in outdoor locations. The type of conduit used must be suitable for the environment and must be installed in accordance with the National Electrical Code, often abbreviated as NEC. Overcurrent protection is necessary to protect the circuit from overload or short-circuit conditions. This is typically provided by a circuit breaker or fuse sized appropriately for the circuit. The overcurrent protection device must be readily accessible and properly rated for the application. It is important to note that electrical codes can be complex and may vary from one jurisdiction to another. It is always best to consult with a qualified electrician or electrical inspector to ensure that the electrical installation meets all applicable codes and standards. Ignoring electrical codes can result in serious safety hazards, including electrical shock, fire, and property damage. In addition to the technical requirements of the electrical code, there are also some practical considerations to keep in mind when wiring a hot tub or spa. First, it is important to plan the installation carefully. Consider the location of the hot tub or spa, the available power supply, and any potential obstructions. Second, it is important to use high-quality materials. This will help to ensure the safety and reliability of the electrical installation. Third, it is important to follow all instructions carefully. This includes the manufacturer's instructions for the hot tub or spa, as well as the instructions in the National Electrical Code, often abbreviated as NEC. By following these tips, you can help to ensure that the electrical installation for your hot tub or spa is safe, reliable, and compliant with all applicable codes and standards. When using polyvinyl chloride conduit, often abbreviated as PVC, for outdoor electrical installations, it's essential to understand its limitations and proper usage. Polyvinyl chloride conduit, often abbreviated as PVC, is a popular choice due to its resistance to corrosion, ease of installation, and relatively low cost. However, it's not suitable for all applications. Firstly, polyvinyl chloride conduit, often abbreviated as PVC, is susceptible to damage from ultraviolet, often abbreviated as UV, radiation. Prolonged exposure to sunlight can cause polyvinyl chloride conduit, often abbreviated as PVC, to become brittle and crack, compromising its protective function. Therefore, when using polyvinyl chloride conduit, often abbreviated as PVC, outdoors, it should be painted with a paint that is specifically designed to protect it from ultraviolet, often abbreviated as UV, radiation, or use polyvinyl chloride conduit, often abbreviated as PVC, that is rated for sunlight resistance. Secondly, polyvinyl chloride conduit, often abbreviated as PVC, has a limited temperature range. It can become brittle in cold temperatures and deform in high temperatures. Check the manufacturer's specifications to ensure that the polyvinyl chloride conduit, often abbreviated as PVC, is suitable for the expected temperature range. Thirdly, polyvinyl chloride conduit, often abbreviated as PVC, is not as strong as metal conduit. It can be easily damaged by impact or crushing forces. Therefore, it should be installed in locations where it is not likely to be subjected to physical damage. Fourthly, when installing polyvinyl chloride conduit, often abbreviated as PVC, it's important to use the correct fittings and adhesives. The fittings should be specifically designed for use with polyvinyl chloride conduit, often abbreviated as PVC, and the adhesive should be compatible with both the polyvinyl chloride conduit, often abbreviated as PVC, and the fittings. Fifthly, polyvinyl chloride conduit, often abbreviated as PVC, must be properly supported. The support should be spaced according to the National Electrical Code, often abbreviated as NEC, and they should be securely fastened to the structure. Sixthly, when running conductors through polyvinyl chloride conduit, often abbreviated as PVC, it's important to avoid overfilling the conduit. The National Electrical Code, often abbreviated as NEC, specifies the maximum number of conductors that can be installed in a given size of conduit. Lastly, polyvinyl chloride conduit, often abbreviated as PVC, is not suitable for use in hazardous locations or where exposed to flammable liquids or gases. In these locations, metal conduit is required. Remember to always consult the National Electrical Code, often abbreviated as NEC, and local codes for specific requirements and restrictions.